Hello everyone, I'm Liao Peiyong from Zhang University. Today I will present our work, Understanding Code Reuse in Smart Contract. This is a collaboration work with Xiangping, Chen, Yixin, Zhang, Yuan, Huang, and Zibin, Zheng. Smart contracts are the programs running on the blockchain system such as Echelon. Specifically, user can call the smart contract by sending transaction to them. The execution result of the transaction will be stored in the blockchain and remain immutable, which makes smart contracts suitable for trustless scenarios across multiple users. The smart contracts on Echelon are primarily written in Solidity. Solidity is a contract-oriented high-level programming language that is influenced by many traditional object-oriented languages. In particular, there are three kinds of contract-level code blocks in Solidity defined by three different keywords: contract, interface, and library. The contract, similar to the class in object-oriented language, contains some state variables and functions. The interface is the abstract contract whose function cannot be implemented. And the library is the contract used to encapsulate common functionality. So in Solidity, contract-level code block is the base code reuse unit. We define this contract-level code block as subcontract to avoid confusion with the term subcontracts. And we conducted our analysis by the granularity of subcontracts. With the popularity of smart contracts, more and more smart contracts have been published on Echelon, which caused a large collection of similar contracts by code reuse. We conducted an empirical study of code reuse in smart contracts for understanding the code reuse situation in smart contract ecosystem. And our research suggests that the code reuse in smart contract is quite frequent, because about 26% of subcontracts are reused, and the average chance of reuse is 14.6, and the top 20 reused subcontracts are almost all related to ERC20 token, which reveals that the current smart contract ecosystem is very homogeneous. And last, we summarize 7 types of code revision in smart contracts. Next, I will introduce the overall framework of our approach, which consists of 4 main stages: data collection, parsing and tokenization, preprocessing, and detail analysis. At the first stage, we collected a total of 146,452 open source smart contract projects from August 2019 from Echelon. At the second stage, we used a Solidity parser to extract the syntax information from source. We used it to port each subcontract in each project to its AST representation, and then we tokenize each subcontract based on its AST to generate its token sequence. The goal of processing is to duplicate the dataset and to remove empty subcontract. After we analyze how many identical projects the dataset contains and how many different creators created this project, we found that there are 2 cases. A large number of creators created several identical projects separately, and very few creators created a great number of identical projects. Considering these 2 cases, we remove duplicated projects by their creators. After this, we also remove the empty subcontracts which are meaningless for the analysis. The total number of non-empty subcontracts is 285,891. At the last stage, we perform the detailed analysis according to the following 3 research questions. RQ1, how often do smart contract projects use subcontracts? RQ2, how are the subcontracts they are reused most? RQ3, how do developers revise subcontracts in code reuse? Next, I will introduce 3 different code reuse detection rules we used. The first one, code reuse. The names and the token sequence of 2 subcontracts are the same. The token sequence contains the syntax information of the subcontract, while the name usually contains semantic information about the functionality. The second is code reuse with renaming. Two subcontracts have the same token sequence but different names. In some cases, the developers may change the name of the subcontract due to the naming rule required by their team. The last one, code reuse with revision, only the names of two subcontracts are the same, and the syntax similarity between these two subcontracts are more than a specific threshold, and the one released earlier is considered as the original version, while the later one is the corresponding revised version. In RQ1, we want to understand the overall situation of code reuse by code clone. In smart contract, we use the code clone detection rule to find out the code reuse instance, and two subcontracts with the same name are not allowed in a project, so we also use the code reuse with renaming rule to analyze the proportion of code reuse within project and across project. First, we identify 62,807 unique subcontracts. Of these unique subcontracts, 26% of subcontracts are reused about 14.6 times on average. The maximum times of reuse exceed 10,000, and there are more than 2,000 subcontracts reused at least 10 times. And in the question, how are the subcontracts reused within and across project? The result is, for within project reuse, the number of projects where within project reuse exceeds is only 1,288. It shows that the most subcontracts only appear once in a project, and code reuse within project is infrequent. For across project reuse, an average of 4.6 subcontracts in each project are reused by others, and 91.11% of all the projects contain at least one subcontract which is reused by others. In RQ2, we find out the top 20 most reused subcontracts. In addition, Solidity spotted inheritance for code reuse, which allowed the developers to design a new subcontract to extend an existing one. So we also identify the top 20 base subcontracts they are inheriting most. Table 1 lists the top 20 most reused subcontracts and their reuse time. It is noticed that these 20 subcontracts are widely reused in smart contract development. For example, SafeMath is a library that provides SafeMath operation to avoid security vulnerabilities. HonorVault is a subcontract to implement ownership and access control. Other subcontracts such as ERC20, ERC20 interface token, basic token, standard token, and so on are the common components in the ERC20 token standard. So we stress that the current smart contract ecosystem is very homogeneous, and the major projects are all oriented towards the ERC20 token. In Table 2, we list the top 20 most popular base subcontracts. Almost these base subcontracts have already appeared in Table 1. In other words, the most reused subcontracts are those base subcontracts inheriting most. So the inheritance is indeed the most common way of code reuse in Solidity. For RQ3, we want to investigate into whether the developers revised the subcontract they reused and how they revised them. It is very common for the subcontract to have the same name but different token sequence, since the developers may modify the subcontract during reuse to get a version that fits their needs. We find out the top 20 subcontracts with the most version, and then calculate the syntax similarity between different versions of each subcontract. We perform our analysis considering whether developers revise the subcontract during reuse and during reuse by inheritance, and finally analyze how developers revise the base subcontracts. Table 3 shows that the top 20 subcontracts with the most version, and Table 4 shows that the top 20 base subcontracts with the most version. For each version of each subcontract in tables, we consider it as an original version and use the code reuse with revision rule to got all possible revised versions for it. Specifically, for each original version, we calculated the syntax similarities between it and other version. If a version has a similarity exceeding 0.9 to the original one and it is published later, it is considered as a revised version. And then we calculated the percent of code modification for each subcontract. The percentage of modification of this subcontract are not remarkably high, which shows that the code modification by developers are uncommon. One possible reason is the security requirements of smart contract. The developers who do not have sufficient experience may reuse without any modification, and on the other hand, smart contracts are mainly applied in token application which already has many templates without the need to make any modification. In last question, we choose 355 subcontract version pair to manually compare their source code for analyzing how the developers modify the subcontract, and this sample of subcontract revision can be divided into 7 types. Subcontract type. The developers may revise the subcontract type during reuse according to its application scenarios. Inheritance. When the developers want to make the reuse subcontract more functional, they may add or modify its base subcontract during reuse. State variables. The developers may remove or add state variables in the subcontract during reuse. Functions. The developers may also add or remove functions in the reused subcontract. Events. Events are used to collect EVM runtime information. The developers may modify the events to record more or less runtime information. Visibility. When reusing the source code, the developers may change this keyword when it is necessary to adjust the visibility of a function or variable. Using library. For example, in case 10, the developers has added the statement using safemask for uint 256 to use the safemask operation defined in the library safemask. For a better understanding of smart contract ecosystem, we studied code reuse for open source smart contract on Ethereum. At the granularity of subcontract, we first analyze the overall profile of the code reuse in smart contracts, then identify the most reused subcontract, and finally discuss if and how the developers revise the reused subcontract. The conclusion is the code reuse in smart contract is very common. The smart contract ecosystem is homogeneous, and we also find that the revision behavior in smart contract is infrequent. That's all. Thank you.